It is Monday, and the weather is pretty nice compared to where we were a week ago, and a week before that, and the week before that. We had a lot of heat in the area, in the Central Valley, over 100 degrees, well over 100. I had 111 in Livermore a week or so ago. Very different now. Let's take a look at the current satellite image, and you'll be able to see that we've got fog and low clouds kind of showing up along our coastal sections. It's deeper, right? So the marine layer is pushed further inland. That's in response to these disturbances offshore that are just chiseling away the high pressure. So what you can see right off the bat is, let's see, I'll move this over here. You can see the fog pushing in through the Nicasio Gap, low-lying gaps, right? So the fog gets in, fog coming in at the Golden Gate Bridge, clearly, and all enshrouding the East Bay Hills with fog. This was about 9:30 this morning. And then Monterey Bay into the Salinas Valley, a low-lying gap as well. If I back out a little bit, let's see if I can do that. Back out, you can see, move this here. Not real good with these tools yet, but I'll get there. Shelley Fire, right there. That's the number one. That's the first thing you notice. Not much smoke coming off that thing, right? And then here's the fog. And then number three, that's the cumulus monsoonal moisture, unstable air mass, higher humidity, a few fire starts from a few thunderstorms down there over the weekend, but nothing that seems unmanageable. Everything seems pretty manageable. And I guess the thing to note it right away is look at how the lack of smoke in the Central Valley. You don't need an air quality monitor to tell you that that's a pretty clean, especially in the morning hours. That's a pretty clean satellite image representing a very clean air mass for the most part. Move this over here, and then we'll go look at these. This is a four-door profiler. The reason I show this is we talk about it last few times. It's on my links page. Time runs. Let's see if I can do this. Yeah, time runs this way. So this is later. This see the tip of the arrow. That's pretty much trying to be now, and so that is the depth of the inversion. So the cool air down here, you can see the purples, right? And representing warmer temperatures, the darker colors or the hotter colors to the north. So to simplify the heck out of this thing, just go, there's your inversion, the depth of the marine layer, and then there it's about 2,000 feet. So that's, boom, there you go. Coastal hills average about 1,000 feet. I know they go higher, they go lower, but let's just average them at 1,000. You're at 2,000 feet, so all the cooling it's up into the delta. So let's see how this profile image from this morning, and this is at Fort Ord. It's an acoustic profiler. They're awesome. Let's see how it equates to real boots on the ground stuff. And what we'll see is, well, Sacramento, or let's say Modesto, 79 degrees at about 10:30 in the morning. Sacramento not at 90 degrees, but at 73 degrees and 81 degrees. And if we go up further, let's see how Redding's doing, because they were nasty. Last week at this time, we were doing 100-degree readings in Redding at this hour. And in fact, right now, Redding is at 82 degrees. So that's a direct symptom of the depth of the marine layer, of the profiler, what we just saw. So what we see here, when you see this, you go, okay, when's it going to cool down? Well, it's cooled down. You can also see, if you look here, you can see that, oh heck, it's been cool for the last 24 hours. The marine layer has stayed over about 2,000 feet. And marine layer doesn't always mean fog. It's just cooler, moisture air from the ocean. It's maritime air, essentially, cool maritime air. So just because the marine layer let's say the marine layer is 2,300 feet deep, or the profiler is showing 2,300 foot deep marine layer, there may be no visible fog in there, but it's cooler moisture air. Yeah, again, you knew that. Okay, so we can go to the beach because everyone likes that. This is the Surfline camera, which right? I mean, I'm not at the beach, but I can be at the beach and I can see what's happening. First of all, it verifies what we saw on the visible satellite. Yeah, there is fog. I'm looking at, this is kind of old school, but I look at the trees. I go, first of all, those trees look like they're dead. But secondly, I'm like, well, they're moving a little bit. So there's a little bit of wind out there. And we can check that we can go right down here and go, what's the wind doing? Right now, this is Surfline. They have such good content. 7 knots out of the south-southwest. So I don't know if you can see my little hand here. Let's see if I can make this go here. So that's a southwest wind. That's where it says 7 knots. and the tide is dropping out. What else do you need to know about the ocean, right? It's money. And if you want to switch up cameras, you can go here. I pay for a subscription, but you can go there and just have to sit through some ads. So that's another shot. That's Ocean Beach Overview. This is Ocean Beach South. And if as a surfer, you check it out all the time. And then this guy, they might be striper fishing right now, but it's just a great tool. Okay, so let's do this. I'm gonna come back here. I'm gonna wind this down. First thing I want to show you is this is the 500 millibar vorticity. Sounds scary. Ooh, vorticity is just spin. Picture a river, a rock in the river. Behind that rock, you know those eddies you get? It's vorticity. It's basically shear. It just shows you where there's where things are tumbling. That's it. Where things are tumbling, and when they're tumbling in a stormy condition or a unsettled condition, they're tumbling counterclockwise. Right? The vorticity is rolling that way, and when they're in a clockwise rotation, it's a more stable environment. So if you look offshore here, I'm going to draw a box, and I'll put it in. See if I find my box. I know this is turning into more than you wanted, but let's just do it. So there's kind of weird. See that yellow blob offshore? That is vorticity. And so I'll keep your eyes where it was. See that spin right there, right offshore? So that's vorticity. Which way is it rotating? Counterclockwise. So, and you can see vorticity going the other way if you go downstream. But the first thing I want to show you on this, and I love this, I personally believe the planet's alive. I just do. I'm not a religious guy, but I just go, yeah, this thing's, look at this thing breathe. This is the planet Earth. This is the northern hemisphere, a portion of it. This is over the next so many days. This thing is a living, breathing organism, for crying out loud, right? How do you not see that, right? I mean, you know that, but I'm just saying it's just when you see it in fast motion like that, and then you see sort of the fluid dynamic component to this, and then just realize what's going on, not just in the atmosphere, but in the oceans too. It's all connected. It's all connected. And the reason everything's going that way is because the Earth is spinning. It's being thrown to the right in the northern hemisphere, or wind parcels are being thrown to the right in the northern hemisphere because of the rotation of the Earth. And that's why you have a jet stream, and that's the reason you have vorticity, quite frankly. So there we go. Well, so what am I trying to show you here, besides all that really cool imagery, is if you can see us again, if you can kind of pick out the West Coast, see that there's a constant parade of counterclockwise vorticity areas, vorticity, moving through the area to the north of us. See that one just to the north of us there? These have an impact on us. So if you look at the climatology for the next couple of weeks, it shows us average temperature or below average. I would buy that, because last week when we had this pattern, the pattern that we had that was so hot, we didn't have that. It was more of a stagnant, everything going up over the top. This is like a parade of energy, of shear going by to the north and just offshore. That is enough to disrupt the Pacific high and give us temperatures like these. So you're like, well, 97 on Friday, that's pretty. Yeah, it is, but that's inland. That's hot inland. But around the bay, if you look at these temperatures here, like these temperatures are what most of us are living in. So it peaks at about 87 degrees on Friday and Saturday, and then in the inland Bay Valleys, that's 87. That's Evergreen, that's Morgan Hill, Gilroy, places like that. So a good forecast, a good week ahead. Fire danger always high, but not as high, and air quality a heck of a lot better. Okay.